Good morning, everyone. We will start in just a minute. All right. Good morning, everyone, and welcome to Resilient Trees for a New Climate, a webinar, first in a series of 3, hosted by Canopy. Canopy is a community-based organization that plants trees on the Mid-Peninsula and provides public education and stewardship training. I'm Igor Lachin with University of California Cooperative Extension, and I'd like to just briefly introduce our hosts and my co-panelists today. So I'll stop my screen share for a moment so you can see everyone's picture, and here they are. With us, we have Dave Muffley, the former head arborist at Apple and also an oak specialist. And Dave maintains the wonderful website Oaktopia. If you haven't seen it, I highly recommend it. And they will share with us his experiences with oaks in a changing climate. Also with us is Dr. Eureka Spotswood, senior scientist in the Resilient Landscapes program at San Francisco Estuary Institute. And Eureka will share with us the importance of native biodiversity in urban forestry. And we have our wonderful hosts, Canopy. We have Elise, the tree programs director. She will be our tech support, as will Natalie Brubaker, the head of education at Canopy. So I'm going to go back to sharing my screen and we will advance through the slides. Now, just a little bit of logistics. If you have any of the questions for the speakers, please put them into the question and answer feature, and we will answer questions as we can. And then if anything remains unanswered, we will still answer the questions and post them on Canopy's website. So all your questions will be answered. If you need technical support, on the other hand, please click the chat button and our tech support, Elise or Natalie, will help you out. So questions in the question and answer, technical issues into the chat. And you will receive a survey as you exit the webinar. Please fill out the survey because it helps us out immensely. And for those of you who are looking for ISA credits, you have to fill out the survey. No survey, no credits. And just a reminder that the webinar is being recorded. And I think that's all I have as a way of introduction. Somebody correct me, Natalie or Elise will correct me if I've forgotten anything. I don't hear corrections. Okay, we're gonna move quickly before they can correct me. So we will start us off with me. And this is just a brief introduction to climate change and urban forests. And I will go through this fairly quickly. There's a few reference slides at the end if you wish to try applying some of these ideas yourselves. But in essence, the point of this entire presentation is that we should really think of our cities, of our urban forests, as shifting. The current climate in Los Angeles in 100 years will shift to resemble the climate of somewhere in Central America, depending on the projection you go with, either Belize City or San Jose in Costa Rica. So again, we know that urban forestry is a long-term endeavor, that planting a tree is a 50 or 100-year decision. And so what I would argue is we really need to think about where we're going to be climatically 50 or 100 years from now. So I'll briefly review some of the climate change challenges to our urban trees. I'll introduce you to a method we used and we found useful in assessing impacts to our current urban forests. We'll share a little bit about some of the other methods we can use, and then we can leave the discussion and the questions for the end of the webinar, but the last 5 slides provide some of the more detailed guidance in case you would like to implement this method yourself. So just a brief review of adaptation ideas, and up here you can see the CalAdapt website, which I will be referring to many, many times over the course of this brief presentation. You really want to understand climate change and its impacts in your area. So kind of be specific. You also then want to understand the resources you have, the tree species, your available or unavailable water, and then your pests. And then once you have those two reasonably well understood, you want to envision the future conditions. And you can do that in a number of ways. One easy way is to look at the so-called extreme events, which have now become much more common, and see how your urban trees perform during those so-called extreme events. And one good example would be the drought we had from 2013 through 2016 in Northern California. Southern California, I think, is still having that drought. And then once you've done all that, you can try to envision your future urban forest. And I would argue one way to do it is by consulting the folks who are managing urban trees in places that are today warmer than your own city, and that today have the climate that your city will have in 100 years from now. So let's just go briefly through the challenges. We know that a longer season, this is because, remember, climate change will cause the minimum temperatures to go up. Our growing season becomes longer. That's potentially good, but it also means that we need more water. We need more resources for those trees to grow. So a longer growing season, kind of by definition, increases your water demand. Again, because we're increasing the minimum temperatures in winter, we know that our pests like that as well, and they will have a longer season as well. So here's an example from forestry where you had 1 generation of beetles, now you have 2. We're seeing roughly the same thing in urban forests. Insect development is dependent on temperature. And so with higher temperatures, you get faster development and faster life cycle. So again, where you had 1 or a few generations of an insect pest, now you may have multiple generations. Aside from higher minimum temperatures, we also are going to see higher maximum temperatures. This is the plant heat zone map. Everybody's familiar with the USDA hardiness maps, but very few people seem to use this heat zone map. But this shows you the number of really hot days in your area. And we're expecting this map to shift as well. And so in cities, now remember, we are used to dealing with excess heat, but with climate change, we will have excess heat. And you can see this, that people often say that you can't really feel climate change. That's one of the difficulties with conveying the seriousness. But these cities, and this is a selection of the cities that have gained the most heat in the last 50 years, some of them have gained over 3 degrees of Fahrenheit. I think that's actually, that you can actually feel that as a human. So one thing, of course, that those of us who are engaged in tree management or tree work, this is something you have to be cognizant simply because of your own work crews or yourself. So the increase in maximum heat, I think, is going to be one of those things that really challenges not just trees, but humans as well very directly. There's a few other challenges, and I'm going through this fairly quickly, but it's more of a reminder. The 4th challenge is the issue of water. For rainfall, the models are a little bit difficult to interpret, but I think if you kind of boil down the various model outputs, you end up with a few messages. One is that we will have more variability. So it'll be more droughts, more heavy rainfall. That's both are possible. I know it sounds a little strange. And one of the results of this is that there will be more time between storms. So while the total amount of rainfall might not be lower, it will come down in fewer larger storms. And for those of us who manage trees, the question is, well, what do you do with those trees in between the storms? And just the bottom line before we go down a rabbit hole of climate modeling, remember that we know temperatures are going up. So irrespective of what the rainfall models say, you know that your tree is going to need more water simply because of those elevated temperatures. It will use more water. Now, when it comes to snowpack, unfortunately, the models are really clear, and they're clear in the very bad direction. We are going to lose much of our snowpack. Now, California is predicted to lose about half of its snowpack by the end of the century, which is good compared to Arizona, which is predicted to lose almost all of its snowpack by the end of the century. And remember, we store our water, so to say, in snowpack from year to year. That's really what gets us from year to year to year. And with a decline in snowpack, it just means that there will be more competition for the water that's available. And we all know when there's competition for water, urban trees tend not to be at the front of the line. So again, water is going to become more difficult. A couple of other things. One of the interesting challenges with water is that of flooding. I'm not going to spend very much time on this. I like this graph. I just like to use this graph to remind everybody that when people say, oh, the climate models and predictions, they're all pessimistic, that's actually not what's happened. This is one prediction that's really easy to verify. The sea level rise projections are in this gray triangle, and you can see that the actual sea level rise is at the high end of the projections. So just kind of think about, when you think about the other projections, you know, some of them are more optimistic than others. It seems to be that our most pessimistic predictions are barely capturing what's happening. So yeah, think about that. The final challenge, of course, is fire. And again, with both flooding and fire, this is one of those things that you either are aware of and are a big issue in your area or aren't. But again, you will have to deal with it because we know fire is correlated with temperatures. So we don't get too many fires when it's very cold, again, especially in our climate when cold and wet periods coincide. But as temperatures have gone up, that fire season has expanded. So where we used to have a fire season in 1900 that was really limited to the summer and fall, now, simply because of rising temperatures, that season has really expanded to include, in some cases, over half the year, in some cases, almost the entire year. So what's the consequence of all this? Well, the consequence is that some common trees that we use today will probably not survive, or they will not perform well in our future urban forests. And this has been worked out really well for agricultural crops. This is a paper that was published in 2011 showing a reduction in crop yield for a number of crops with climate change. And what we would really like to have is, we'd like to have the same thing for urban trees, but we don't. There is no such modeling study for urban trees. And so we're left with trying to figure out what kinds of trees are likely to succeed and what kinds of trees are not, using other methods. And I'm going to show you one of those methods. Of the various sorts of challenges, we decided that focusing on the increased temperatures would give us a reasonable proxy for the other effects of climate change. So we basically asked, is there a city today with the climate that's predicted for my city, for the city that I'm interested in 50 or in 100 years? And then the second question is, do my favorite trees thrive in that other warmer city? And if you do this, you essentially substituted space for time. And this is the space for time substitution method. And that's what we'll be covering briefly in the next few minutes. In essence, if we look at a pair of cities, so let's say I'm living in Eureka, I'm interested in how my trees will do 100 years from now. Is there a city today with the predicted climate of Eureka 100 years from now? Yes, it turns out that city is Berkeley. And if we compare the trees we have in Eureka with the trees that grow in Berkeley, now again, I'm interested in Eureka, that's where I live, we discovered that actually all of the street trees in Eureka are also present in Berkeley. Street trees in Eureka will probably be okay as the climate warms up. We can do this for any pair of cities. Again, all you're doing is you're pairing up the current maximum temperature with a predicted maximum temperature. So if you live in Fresno, your predicted temperature 100 years from now is 108 degrees. Yikes. Is there a city in California today that has that temperature? Yes, it's El Centro. Again, we do the comparison, but we only find that some Fresno trees are found in El Centro. And we would conclude from this that maybe we need to start adjusting our palette, because if we don't, it's likely that 100 years from now, when the climate of Fresno resembles that of El Centro, not all of our trees are going to survive. So we actually did a study of this. We picked 16 example cities, and here they are, and we paired them up. And again, you take the prediction, climate change prediction for 100 years from now. So for Eureka, we said it'd be about 69 degrees Fahrenheit. And is there a city today with that kind of temperature? Yeah, it's Berkeley, and so on and so on. And here is what you end up with. So if you live in someplace like Santa Monica, your climate is predicted to resemble King City. If you live in someplace like Berkeley, our climate, and I live in Berkeley, our climate is predicted to resemble that of Santa Ana 100 years from now. So when we do the tree species comparisons, here's what we get. And this is really the most important slide here to kind of look at, ponder, and consider. Some cities will lose their common tree species, according to our model. If you look at something like Eureka, remember we're comparing the tree species in Eureka and in Berkeley, it turns out Eureka actually is probably okay. We found all of the common tree species in Eureka growing in Berkeley. And so on and so on. Berkeley and Santa Ana, well, we looked at the species in Berkeley, then we went to Santa Ana. Almost all of the Berkeley species were found in Santa Ana. But remember the Fresno and El Centro example, only about half of the species in Fresno were found in El Centro. And then when you look at some of the other cities like Susanville or Yuba City or Stockton, they really seem to be poised to lose their tree species with climate change, because in some cases, none of the common species were found in the warmer city. And if you kind of try to summarize this across California, this is sort of the image you get. It's really the inland climate zones that seem to be most at risk of not being able to retain their common tree species. Now, again, we've published this study. If you'd like more details, it's in the paper, and I'm happy to talk to you afterwards. I would just note that this was a little surprising to us, actually. So we ran these results through a couple of books. We said, well, we can consult the experts by looking at books. And we were really mostly interested in seeing whether what the books say where trees grow and how much warmer of a climate they can withstand, whether that lined up with the output of our model. And I'm not going to spend too much time on this, but in essence, in every single case, the books were much more optimistic than came out of our model output. And I think this reflects a certain reality of things. When you look at professional opinion books and instruction manuals, they really are making an assumption that you will do the right thing. For example, you will water those trees when a drought hits, or you will add more water as temperatures rise. And our model or our experience sort of shows that maybe that's not what actually happens in practice. So even after we tried to reduce our giant list of tree species that are going to be lost, we still ended up with some really common trees that don't seem to be well suited for a warming climate. Now, this is not a universal prescription. You really need to look at your city and then its comparison. And that's actually on my website, you'll find a bunch of these city pairs, and you can use that to sort of guide you. But on the whole, we found that somewhere around 55 of the really common species are going to be unsuitable for a warmer climate. And some of these species are really, really quite common. Now, as I said, I have an entire set of slides at the very end that will guide you through implementing this space for time substitution method if you wish to try it. But I just want to spend a couple of moments talking about what other things we can do to try to figure out which trees are likely to do well in a warming climate and which ones aren't. And here are some ideas. So let me try to go through these kind of one at a time. I already talked about the extreme events, and I think for some of us in the Bay Area, we really have gained some understanding in the 2013 to 2016 drought about how well some of our common trees are doing. And again, I've talked about the space for time substitution, but I do want to talk a little bit about the natural range of your trees. If you're using native trees, then it's really highly useful to look at the native range of those trees. Again, this doesn't work so well if you're using trees that are not native to California, but at least for California and sort of California floristic province trees, this is quite useful. When you compare two very common trees in the Bay Area, the coast live oak and the coast redwood, you can see that in the case of coast live oak, the range extends way south, right? All the way into Baja California, essentially, into Mexico. Whereas when you look at coast redwood, you can see that actually we're sort of in the Bay Area at the southern end of its range, and the only things further south are really on the cold, dark coast in places like Cambria where it's never sunny. But if somebody then presents you, and again, we're talking about Bay Area with a choice, well, should we try coast live oak or coast redwood? They're both native. Well, again, remember that as climate warms up, the ranges are going to shift northward effectively. So that if you're already at the southern end of the range, as that range shifts northward, you're going to be left behind. So probably not a good idea to plant redwoods. Whereas, again, in contrast to coast live oak, you can get this information from calflora.org, for example, and they have some really, really nice information about native ranges. And then the only other thing I would suggest is we really need to start recognizing landscape situations that favor water deficit. Often that water deficit is associated quite directly with excess heat. If you look at these trees in the parking lot, there's all that heat reflecting from the surfaces. And yes, I know your landscapes hopefully probably differ from these, but be aware that very often we are asking these trees to perform in very, very difficult situations. And with climate change, this will become that much worse. So again, are you really kind of trying to push this tree outside of its envelope of adaptation? So just to conclude, we are trying to adapt. This is really the adaptation bit when we're talking about climate change. So we remember that climate change management really involves at least three components: abatement, which is stopping of use of fossil carbon; mitigation, which is the removal of carbon dioxide from the air, and trees are one of the few things that can do that. And then the third leg of that wobbly stool is adaptation, where we're really trying to adapt our landscapes, our ecosystems, and ourselves to some of the inevitable consequences of climate change. So this is really what we're talking about today. This is just a reminder, but so if we accept that we're going to have warmer and probably drier conditions, I would argue start by assessing your tree's environment. You then go into this idea of a tree's climate envelope. Is it at the edge now? Can you use space for time substitution to figure out if it'll work in a warmer climate? And then can you use references to help you? And I would really emphasize Selectree from Cal Poly, a fantastic reference. I would argue this is the moment to consider the major pests. The UCIPM website has the information on all of the major ones, and the pest vulnerability matrix we constructed, which is on my website, will help you quickly line up your tree species and see what the major pests are. And the final thing is to understand the water needs. WU calls the water use coefficient of landscape species. That reference is a good starting point. And then there are good calculators for how to calculate the water needs. And then, of course, you'd still, after all that, have to apply the water properly. So that's it for me. I will stop here. And again, I will just a sneak peek. There's your space for time substitution instructions, but I will stop here and I will stop my screen share. And I think I will give Elise and Natalie a moment to interrupt me if there's something strange going on. No? I'm not hearing anything. Okay, quickly move on before they can say something. I want to introduce our next speaker, Dave Muffley, and I think Dave is very familiar to most of you, our former senior arborist at Apple, but also really the person with the greatest understanding of oaks, especially oaks in warm climates. So without any further ado, Dave Muffley.
Hello, everybody. Hopefully you can hear me. This is my first webinar. So introducing myself, I guess you couldn't see me in the beginning. So I'm going to go ahead and go into my slides. Okay, hopefully somebody's going to speak up if you can't hear me. Can people hear me? Can somebody indicate?
Yes, you're good.
Excellent.
Yeah, you're good.
Thank you. Okay, sorry for that. I'm a little out of practice, and this is the first webinar that I've ever done. So first off, I want to thank Igor for what was a really excellent introduction to the science of climate change as it applies to trees. So I've been wandering down the rabbit hole of trees and climate change now for 31 years. The photograph on your screen is a blue oak. That is the dish at Stanford, and that's where I began 31 years ago, watering oaks in the wildlands and moved to collecting acorns. So back then, when we started through Magic is there in Palo Alto and has had a contract with Stanford University for nearly 40 years to grow oaks. And we've grown probably 3,000 to 4,000 oaks. And it all began there on the dish. And the dish at Stanford is also where Steve Jobs loved to walk. And when he went looking for an arborist, he told his headhunters to find the arborist at Stanford. And that wasn't exactly me, but it was close enough. So we're beginning with the blue oak because it's a beautiful, iconic native species. But what we learned there on the dish was that we had huge trouble getting it to reproduce. We had huge trouble even finding acorns. So, but before we get into that, there's an article that just came out that talks a lot about oaks. People ask me a lot, Dave, why are you so focused on oaks? Well, the truth is, I'm not the one who's so focused. It's nature. I'm the messenger. If you look at native ecosystems within our evolutionary zone, they're mostly oaks. So this is a brand new article coming out in Scientific American yesterday. I urge you guys who are interested in oak trees and how they're going to adapt to climate change to have a look at that. So here we are back on the dish. You can see above, that's the big dish. And then you see the 2X tree shelters. Very few organizations have used tree shelters. We've used them with amazing results now for 30 years. And here you can see a beautiful blue oak early in the project. And at Magic on the Dish is where I learned to collect acorns. I've collected a lot of blue oak acorns, I've collected a lot of valley oak acorns, and I've collected an absurd number of coast live oak acorns. And what we learned over that time of 30 years, so back in 1990, even in the 80s, we at Magic were talking about climate change. And every site at Stanford, we planted all 3 species because back then we didn't know where the climate was going. Well, it's 30 years later, and I can tell you some things now. One of them, valley oaks, pretty much doing great. Coast live oaks doing okay, although we're starting to see trouble in mature trees throughout the coastal zone. But the blue oaks, they got chewed up by powdery mildew. We hardly have any. I collected probably 10,000 acorns over the years, and we have very few trees. So that may be related to an increase in coastal zone humidities. So I started out with native trees, but then I moved down into the cities. I was Canopy's first program director in 1998 and began experimenting with unusual oaks there. I started my arborist business in 2005, and then in 2007, we planted the East Palo Alto Sound Wall, nearly 1,000 trees. I had full control over the planting. And as Igor spoke about water deficits, water deficit is critical. Drought tolerance, we will need drought tolerance in every tree. So I planted only drought tolerant species and had to go all over the state, and there wasn't that much diversity. And from there I learned that if we wanted cool trees, and this was even before I was thinking about climate change so much, I was just looking at our cities. We need more trees, you guys. So I realized that the industry wasn't going to help, so time to go collect acorns. So in 2008, I did a massive acorn collection, mostly out of the Shields Oak Grove, but starting in to wild collection. And this is a Western arborist article that I wrote back in 2008. You can find this article on my website, oaktopia.org. And also, I'm going to move quite quickly through this presentation. So if you have questions, do go to my website because you can get lost in there on the details. So these, back in 2008, were the first of the new species that I brought. Well, subsequent testing has proved that the algorithm that I used to choose those has proven quite good, because we got to plant most of them and even more on Apple Park. And the results, frankly, have surprised me. So let me start going through some of the science that falls into place. So one of the hot topics right now in academic evolutionary biology and just in general is assisted migration. Can we help trees to move? Climate shifting. 30 years ago, forest ecologists told us, look, you guys, the climate zones are moving and you've got trees with narrow range of adaptation. Their climate zone moves north. The trees ain't going to get up and walk. So that brought the idea of assisted migration. So here we are in 2020, and even Trump is talking about trillion trees. But of course, now we know he didn't mention climate change, and it was kind of a cover to plant species impoverished monoculture for commercial. So, but anyway, everybody's talking about trees. And what a lot of folks don't know is that if you go into the deep science, you're going to find out that forestry is preparing for assisted migration, even though many people, kind of native plant society people who aren't really deep in the science, they don't understand how fast the science has changed over the last 10 years. Here we are, managing consequences of climate-driven species redistribution. Requires integration of ecology. It requires everything. This is a profound challenge. Organisms are moving everywhere on the planet, and they're moving poleward in their respective hemispheres. So if you'd like to know more, if you want to go deeper into assisted migration, Terrea Guardians, they have a collection of the scholarly articles and also kind of more readily available articles. So I highly recommend you look at this and learn where the science has really gone. Landscape architects are talking about it. Have Tree Will Travel. Nature Magazine, how do we plant 1 trillion trees? But we're up against something that Igor, I have to thank Igor, he showed a really nice slide about sea level rise, and it showed the prediction window in gray. And it showed going back to 1990, and it shows where we've been on the curve. That's exactly what those of us who've watched the science, we are consistently at the top of the projections. And if you guys look at the projections for the next 50 to 100 years and look at the top of it, I think you will be sobered. So many people agree that it's time to plant trees, but what trees shall we plant? Well, so here's a question. Perhaps we should ask ourselves, what trees would nature move here if given sufficient time? Because we humans are driving climate change at a pace that outpaces pretty much every event in the paleoclimatic record, except asteroid strikes. This is a big time. So going back to a slightly different version of a slide that Igor showed, is that this is the area of shift. And realize the shift may be even greater than this. This is based on old data, and the data is showing that we're going to be even warmer. So, but again, climate of Los Angeles shifting to Belize City. Now, interestingly, so one thing that Igor did was that he compared urban trees. Well, one thing that I have done is that I've stepped out of the urban matrix and stepped into the wildlands outside of California, which is an unusual step. And I didn't take it without a lot of hesitancy, but it has worked out remarkably well. So look at that shift. Now, know that one of the highest diversity of oak trees, pine trees, and many other species in the world is in northwestern Mexico, immediately to our south and west. Let's go back and look at that. There's the Madrian pine oak woodlands. They are full of oak species, most of which we can't get in California yet because the mountains where they grow are controlled by the cartels. Anytime I've tried to find somebody to collect acorns, they tell me they'd be killed, literally. So it's a little daunting, still working on that one. So I stopped working at Apple 2 years ago, and I've been focused on bringing the new trees to the rest of California since then. So last year, I did a massive collection, more than 30,000 acorns, and we've got 20 or 25,000 of them growing now. So that's what I came up with last year. So the question is, where am I going to collect my acorns this year? Because these will be trees available in the industry in coming years. So now we're going to shift from kind of the broad meta science into the very specific. And I'm going to introduce you to some trees that I think are worth considering for our urban areas. First, Quercus engelmannii, native California tree. So this one's on the Santa Rosa Plateau, which is a wonderful place to see Engelmann oak. Engelmann oak range is essentially from Pasadena down to very northern Baja. But Engelmann oak is very closely related to the other southwestern species. A quick note, many of the oldest oaks in the lower elevation areas of California are 300 to 350 years old, because that's when the last 100-year California drought ended and the oaks were again able to become reproducing. You can check that out, it's kind of fascinating. So this is Engelmann oak in the wild. Well, Engelmann oak has also survived in urban areas in Arcadia and Pasadena, and they have survived for between half a century and a century, and they are integrated right into the urban landscape. So because it's heavily used in Pasadena and points south, we knew that Engelmann oak was useful as an urban species in California, so we began bringing it to the Bay Area. Well, here they are at Apple Park, where they are growing beautifully. Engelmann oak is one of the best urban trees I've ever used. It's not only drought tolerance, but it really tolerates. The way we water our landscapes is often goes from flood them out to dry them out. And there's a lot of trees that don't like that. But Engelmann oak, along with the southwestern oaks and those northwestern Mexican oaks, they are luckily monsoonal tolerant. And that monsoonal rainfall brings summer rainfall, and it makes them tolerant both to our current landscape reality and also right on the path to where the climate models are showing us going. So here's an idea. There's one down in San Diego County. That's kind of the idea of what you'll see with a nice upright Engelmann oak after 50 years. Here's another one, another beautiful big one in Arcadia. And you can see the sidewalk looks pretty old. So I wanted to know, okay, how does Engelmann oak behave with sidewalks? Well, you aren't going to find that anywhere in the literature because nobody's studied it. So I went into the urban areas and took photographs, looked around, and I was pleased by what I saw by comparison to many species. Here's an Engelmann oak that survived in a 60-year-old neighborhood with a lawn. They seem to thrive with lawns as long as there is sufficient soil drainage. So propping, we don't do that anymore. You can see that in the Fallen Leaf Road neighborhood in Arcadia. So here are some wild Engelmann oaks. And if you look, the two on the edges don't look so hot, but the one in the middle looks good. Turns out Engelmann oak is not a really monolithic species. It's more like a bunch of subspecies, which aren't well studied yet, but that'll be interesting to play with as time goes on. There's a young Engelmann oak down in Southern California, and there's a tree that looks almost identical at Stanford that acorn was collected in 2003. Now, these trees are coming into production. They're going to be available for purchase outside of contract grows in California. This is Devil Mountain. Sorry for the bad photograph. So there's young Engelmann oak. They grow beautifully under nursery conditions, and they're coming. Now let's step out of California a little bit. And the oak that's closest to Engelmann oak is the Mexican blue oak, Quercus oblongifolia. It's turning out to be a super beautiful tree, and we have these in production also. That's again Devil Mountain. Here you can see the beautiful blue foliage. People in Southern California would tell you those are Engelmann oaks, but they're oblongifolia. Very, very closely related species, and they behave very similarly. This is Mount Lemmon outside Tucson, Arizona. This is where I collect a lot of the southwestern oaks. This is a big, ancient, probably 300, 500-year-old Quercus oblongifolia on Mount Lemmon. And here in this slide, it's repeated on my website. I won't, but as you go up in elevation on the skylands of the Southwest, including Mount Lemmon, you can see you get decreasing temperature, increasing rainfall, and the ranges of temperature and rainfall match coastal California to a stunning degree. And because of that, we are seeing really good growth in the urban areas. Sorry, I'm a little out of order here. So this is Quercus oblongifolia at Apple Park, growing beautifully, all grown from acorns that I collected, and down in Southern California also. Now let's go back. This is southeastern Arizona. That's Quercus oblongifolia. Now let's look at the range. So you see where the range is from, it goes down into Mexico, half the way to Mexico City. And if you remember the line of the slide that Igor and I both showed you, the line from Los Angeles down to Belize City, you're seeing that we're cutting right through that path. So another accessible one, there's acorns on Quercus oblongifolia. Growing right along with oblongifolia is Quercus hypoleucoides, the silverleaf oak. Beautiful oak. So I learned about this one from Portland, Oregon. It's growing beautifully at Hoyt Arboretum, a tree that grows at 3,000 to 4,000 feet above Tucson and also grows in Portland, should grow in coastal California, and it does. And here again is the range, and once again, it falls onto the line that Igor and I showed you. Here are beautiful young Quercus hypoleucoides coming up. It's a nice moderate-sized oak, and again, we're seeing excellent performance. There they are in nursery production. So another species, this is a picture of Igor from about 2006. He's one of those two people. And that's Quercus rugosa, the netleaf oak, which grows, again, largely, you can see the range. But here, interestingly, rugosa's range goes all the way down to Guatemala. So it's a tree with a really enormous range of adaptation. And we are seeing stunning performance, fast growth in the good soils. There's a 10-year-old tree. The sound wall is 12 feet tall. And so that tree is getting close to 35 feet in about 10 years. So very impressive growth. Here's another one on the sound wall that we planted through Canopy, the East Palo Alto Tree Initiative. That poor tree got hit by a car, and it is recovering beautifully. Gives you an idea why oaks are so tough. Here again, Quercus rugosa at Apple Park, Quercus rugosa in nursery production. Another one, the northern Mexican red oak, Quercus canbii. Those are little seedlings that I grew from acorns collected in Texas. These are the mother trees in Dallas. They're extremely rare in the urban environment, but I have friends in the International Oak Society, so we found some and brought them back, and here they are. They're all over Apple Park. Got 150 of them on Homestead Road, and they have given really stunning performance in a slightly more watered environment. Now these trees are interesting. They don't have typical fall color. This is their winter color. They color in February, drop their leaves for a brief time, and leaf out again. So a couple more species, Quercus fusiformis, the escarpment oak that grows largely in West Texas. But if you go to Arizona, Tucson, this is Tucson, Arizona street tree. So they thrive there, which gives you an idea how tough they are. And I've brought quite a few Quercus fusiformis. These are ones from Alpine, Texas. It's closely related to the southern live oak, which is a tree that has a very long history in California and grows well. So these are the trees. Here's a Quercus virginiana. You'll find them scattered around the Bay Area. These are some just down the road from where I live in Santa Barbara. It's a lovely adaptable tree, and frankly, it's kind of surprising that southern live oak does as well in California as it does. Here's a little comparison. Coast live oak on the left, and on the right is a southern live oak planted at the same time, so you can kind of see a comparison. You get them confused pretty easily. So asking about Mediterranean, yeah, there are proven Mediterranean species in California. One of them is the cork oak. And when you have good soil drainage, it can be a really excellent tree. It's a bad photograph, but you can find old plantings of cork oak all over California. A bunch of them were put in World War II as we feared losing access to our cork supplies from North Africa. Here's cork oak in nursery production, and I thought I would finish with one non-oak. Put in a plug for Pinus torreyana. It's a beautiful, if you're looking for a pine and don't mind big cones, Torrey pine is proving to be one fantastic tree. So I'll end it there, and thank you all very much.
Okay, fantastic. Thank you very much, Dave. So Dave will stop sharing his screen. And we will, thank you, Dave. Cool, that was fantastic. And we will go straight to our next presenter, Dr. Eureka Spotswood, Senior Scientist at the San Francisco Estuary Institute in the Resilient Landscapes Program. Eureka, take it away.
Hi, everyone. Happy to be here. All right, so with that wonderful setup by Igor and Dave, I'm going to round out this group of presentations by talking specifically about the context for native trees in urban landscapes, both within the context of climate change and the broader kind of ecosystem and health benefits that both native trees and all trees provide to us, which is really important when thinking about the suitability of future trees, because we want them to continue to provide the ecosystem services that they can provide into the future under climate change, as well as today. So starting off, why should we focus specifically on native trees? Well, we know that native trees provide, the biggest reason is because native trees provide biodiversity benefits and benefits to other species that non-native trees don't tend to provide as well. So this is showing some work that we did, some work that came out of SFEI, a report called Reoaking Silicon Valley, where we documented the change over time in the species composition in Santa Clara County. And what we found was that the forest from, as it transitioned from pre-European kind of colonization and land conversion to modern urbanization, the tree species diversity increased by about 400 species. So it went from about 20 species to more than 400 species on the urban landscape. And the fraction of native species declined to about less than 4% of the total urban forest today. So that's a dramatic reduction. What that means is that we could plant a lot of native trees while not compromising the non-native trees we have on the urban landscape. And doing so would likely support both the biodiversity of those trees themselves and populations of those trees themselves, but would also support all of the other biodiversity and wildlife that tend to thrive in native trees. So why should we care about biodiversity? Well, we know that we're facing a biodiversity crisis worldwide. So there's been some recent work on what's been called the insect apocalypse, and also documented really large declines in the abundance of many common birds over the past 30 to 40 years. So, and we're facing an extinction crisis within endangered species worldwide. So we know that biodiversity is an issue and is something that we should care about. But we don't tend to think about conserving biodiversity in cities. We think of cities as kind of biological deserts or places that support pigeons and raccoons and maybe not much else. But that's actually not really the case. So there's been increasing amount of scientific evidence coming out over the past 30 years from urban ecologists documenting the really large number of native species, both plants and animals, that do tend to be supported in cities. And what we know from that science is that some places support species better than others, and that it is possible to create high quality habitat that can support biodiverse ecosystems in cities, but it takes some effort and it takes some thought and careful planning. We also know that urban landscapes are predicted to grow by 1.2 million kilometers over the next 20 years. And along with them will come more people, more agriculture, and more human modified landscapes outside of cities. And so the point here is that as urban landscapes expand and as human populations increase, we should expect that their impact will grow. And that means that our urban landscapes we will need our urban landscapes to do more. It will likely isn't possible now and will be not possible in the future to consider conservation as an exercise that happens only outside of urban landscapes. We'll need to think of cities as places where we conserve biodiversity as well. But cities aren't great for people. So there's a number of reasons why this is, but cities come along with a lot of negative attributes that are bad for biodiversity, but also bad for people. So this includes things like air pollution, contamination, and pollutants, a lack of social cohesion, urban heat islands, the tendency to sedentary lifestyles, especially in neighborhoods with sprawling urban form, noise and light pollution, and flooding and other hazards. There are also mental health risks associated with urban living, including stress, schizophrenia, psychosis, and then other health risks such as heat-related illness and mortality and obesity. And this kind of package of negative impacts of living in cities is so widespread. Rob McDonald coined this as the modern urban health penalty, which is sort of an update on the original idea of the urban health penalty was about the increased exposure to disease that occurred before widespread sanitation mechanisms were installed. So we know that urban trees are part of the solution to making cities healthier for people, as well as helping to support biodiversity. So there's the literature on the health benefits of nature is very, very broad. But I'm just going to focus on a couple of studies that have come out that are specific to trees. People have measured lots of things about the urban landscape, looking at park access and the size and quality of parks, and looking at the total vegetation cover, total greenness in the neighborhood as attributes to measure the different dimensions of human health benefits that are associated with nature contact. From that literature, a subset of that focuses either on tree cover or on street trees specifically. So, and the health benefits associated with trees are also widespread. So for example, in the category of physical health, in Toronto, one study found that adding 10 more street trees per city block would increase the self-reported perception of general health by 1%, which was equivalent to $10,000 increase in income and a reduction in your age, equivalent to being 7 years younger than you were. The mental health benefits associated with trees, there's a fair amount of research on this. The proximity to nature in general reduces stress, and this has been found across tons and tons and tons of studies. But specific to trees, in one study in Delaware found that there was people reported experiencing less stress in places that had more street trees and more total trees. And then in England, more forest cover, so forest cover above 20 or 30% was associated with reductions in both depression, stress, and anxiety. There's also, trees has also been linked to a greater social cohesion in a study in Sacramento, and then in a sort of really classic work in Chicago, looking at public housing residents. This was a group of buildings in the same public housing unit that varied sort of randomly in the amount of trees and nature outside of them, and people were randomly assigned. This is a really powerful natural experiment that documented greater social cohesion in the public housing, in the buildings that had more tree cover around them. But there were also quite a few other dimensions of human health that were also documented from that series of studies. And then in the category of physical activity in Seattle, canopy cover was associated with more walking. And then finally, risk of asthma has also been found to be lower in places with higher tree canopy cover. So just a brief overview of the widespread health benefits associated with having trees in your neighborhood. It's also been shown that having more biodiverse environments can also provide greater mental health and restorative benefits. So this is a study conducted in England looking at the restoration that people received from public parks. And what they found was that greater ecological richness, categorized using looking at total vegetation and bird diversity, was associated with a greater sense of restoration in that same environment. Just showing that biodiversity is good it's good to think about conserving biodiversity for conservation reasons, but there also may be a good human health reason to do so. That may be pretty compelling. Trees, of course, also provide many other benefits, including storing carbon, reducing heat island, capturing air pollution, etc. And going back to the specific case of California native trees can also confer resilience. So, for example, what we did at SFEI was to look at using the WUCOL's classification, look at the water use categorization of native versus non-native trees. And what we found is that a greater fraction, as you might expect, a greater fraction of native species are either very low or low water users compared to non-native species. And this is going to be really important under climate change, of course, as we're thinking about needing to conserve this water, the scarce resource of water in California. We've also looked at the other ecosystem service benefits provided by native versus non-native trees in California. And here what you can see is that the trees on the dashed lines are non-native, and the trees in the non-dashed lines are the native trees. And when you're looking at carbon sequestration as the metric across the lifespan of trees from 0 to 30 years, the native trees, and particularly the oaks, are really, really good at sequestering carbon and sequestration in terms of carbon stored per year. This is also true of carbon storage. So total carbon stored across the lifespan is also high in native trees. And then comparing the other ecosystem service benefits like avoided runoff and air pollution and energy savings for trees, for native and non-native trees at the age of 25 years, we found that their native trees are similar. So they are quite competitive with non-native trees in terms of these other attributes that we care about, such as avoided runoff, pollution removal, energy saving, and energy savings and cooling. We also know that tree cover is an environmental justice issue. So this is from these maps, or from some published work coming out of Sacramento, looking at the relationship between neighborhoods that were predominantly African-American versus tree canopy cover. And you can see the alignment between neighborhoods that have that are predominantly Black and lower tree canopy cover. At SFEI, we've done a very similar analysis in the landscape of in the urban area of Santa Clara County. So this is the tree canopy cover across that landscape. So we've looked at the inequality and distribution of trees and parks. So this is the distribution of parks across that same landscape. And what we did was to take the US Census data to relate annual household income and racial background to canopy cover and park access. And for canopy cover, what you can see is a slight rise in the tree canopy cover in your household, around your household at the very highest income, for that very highest income earners. So for households of 200,000, making 200,000 or more, the average tree canopy cover is around 20% versus around 17% in the lower income households. But what you see across the board is that if you are living in a white household, no matter what your income, you are likely to have much higher tree canopy cover than other racial groups. For park area, what you see here is a similar pattern where if you live in a white household, no matter what your income, you're likely to have higher amount of park within 1 mile of your home. However, you do see a stronger increase in park area per person as a function of income overall. So this is just showing the really important relationship, the really important and profound inequity in the distribution of green space and trees. So if we want our urban trees to survive in climate change, and if we know that they are key to providing both biodiversity and human health assets to us, along with other ecosystem services, and if we know that native trees are important for creating resilience and conferring biodiversity, we also know that that urban trees these natural systems are fragile. And in urban ecosystems, there's the potential for problematic for under climate change as heat rises and and the risk of drought increases. There's the potential for problematic feedbacks to develop where heat produces drought stress, which then makes trees more susceptible to insect attack. So I'll finish off just by talking briefly about urban trees and climate change and the potential, how we should be thinking about the particular context of native trees under climate change. And building on Igor's great presentation from earlier, looking at which trees may be suitable and unsuitable under climate change. A recent work by Kendall et al. From 2018 looked at tree inventory data from across 182 cities worldwide. And what they found was that urban trees often have wider niche breadth than in urban environments than their native population. So what this means is that urban trees are more likely to be on the edge of at the kind of extremes of their tolerance for both temperature and precipitation. So what this means is that a very large number of species of trees across a huge number of cities is very likely to be living in a place where, as the climate changes, it's likely that climate will become less suitable or push outside the extremes of that species tolerance. So we should be worried about our urban trees under climate change. And what we know for climate change and biodiversity conservation more broadly is that some species will likely move. Some species, as the climate shifts, some species will adapt and stay in place. And finally, others will go extinct. And so if we consider those categories, some species will need to move. And with trees, this is hard. Trees have trouble moving, and whether we can help them kind of move to track climate change is an open question. But a large number of species will adapt in situ or will tolerate the future conditions in the same place where they are now. And that point, that we also need our landscapes to be able to protect trees that or species that need to stay in place, is an important one, and is often lost in the rush to think about things like assisted migration. So what scientists have proposed that we need is large patches of habitat and corridors. So the same things we need for broader conservation will be needed under climate change in order to help species either stay in place or move to track the changing climate. And we know that urban forests can play a role in this, and that there's already evidence from the eastern United States that trees in urban landscapes are already planted in places that are northward from where they are, from where their native range is, and that this kind of urban forestry practice of planting trees outside their native range in places that are warmer and drier could be a way of helping to support species and helping them move to track climate change. So assisted migration is a viable option for some species, so we should think about which species are potentially most appropriate. So with that question in mind, remembering that we need to think about both protecting species in situ and thinking about who might need to move. One way of looking at this is by looking at climate change projections for species. So the U.S. Forest Service has created what they call the forecasts model. And this is basically a very large number of species distribution models that take current conditions and relate the current species this current species range and the places where species are found to the contemporary climate, and then take the future climate and say, well, where is that future climate going to be, and where will species which areas will likely be the new habitat for species under climate change. So what they produce is maps that show the new habitat in green, the places where the species will potentially be able to move to in the future. The overlap between the current conditions and the future conditions. So those are the places that will likely stay the same, where the species is now and will likely be able to be suitable in the future. And then in red is the lost range. And these are all for the Hadley V1 climate change scenario in 2050. So what you can see is that I'm just going to give a couple of examples of some species that may become newly suitable in the Bay Area, some species that will likely stay the same, and some species that may not be appropriate in the future given these climate change projections. So two species, blue oak and Engelmann oak. So Dave already talked about the Engelmann oak. You can see their potential expansion in the Bay Area for both of these species will either be there's places in the Bay Area for blue oak that are already suitable, and then there are places that will likely become suitable in the future. Engelmann oak is currently not really in the Bay Area, but you can see the green near the Bay Area, places that are likely to become suitable in the future. Valley oak, California black oak, and coast live oak are all examples of species that will likely still be suitable in the Bay Area going forward. And what you can see is a really the sort of speckling showing between yellow, green, and red on the maps in the Bay Area, showing what you're really seeing is at a very fine scale, it's likely that certain places may become less suitable, whereas others will become more suitable. And that's likely going to relate to very, very fine scale microclimate conditions. And then finally, two species that may become unsuitable are coast live oak coast redwood and Pacific madrone. You can see the loss of their range in these climate projections. So with that, what do we need to do? Well, I would argue we should plant native trees in cities. We should plan for new species and consider assisted migration for some. We should plan for existing species and not forget to protect them too. We should place appropriate value on trees, recognizing the really huge human health benefits that are associated with them. And we should not forget to protect large trees. In addition to planting new trees, existing large trees already provide many benefits, and protecting them too is a huge piece of the overall puzzle of making an urban forest that will be sustainable for the future. And thank you. I'd like to thank my funders, including the Google Ecology Program, Robert Wood Johnson Foundation, and others, and my team at SFEI. Thank you very much.
All right, spectacular. Thank you everyone. Thank you, Erica. Thank you, Dave. This was great, and I really want to just reiterate what Erica just said. The large tree issue, that's the elephant in the room. And if you remember Erica's graphs about how all those benefits increase with size, yeah. So losing large trees is really is a really tremendous loss, much more than it would seem. And that's, of course, a discussion for another day. So I will really open it up to Elise, I think. Yes, Elise, to give us some questions. I've tried to answer some of them in the question and answer box, but I'm open to others. So Elise, why don't we maybe steer some questions to Erica and Dave?
Okay, sounds good. So you all have shared a lot of really good questions. Just want you to know that we will be sharing slides and lots of additional resources many of you are asking about very specific questions you might be able to find the answers to at Oaktopia, Dave's website, or you might be able to find on SFEI's website, and lots of things like this. And several of you have asked about studies that were brought up in the different presentations. Igor brought up stuff about agriculture. There were several studies. Eureka brought up this study about tree canopy and racial equity. And so these things we'll make sure to, I'm keeping notes and we'll make sure to share those afterward, just so you all know. So there are a number of questions that relate to the suitability of native trees, like native oaks, for wildlife, birds, bees, etc. And so we know that many, these native oaks in our area have evolved to suit lots of native wildlife. So if we go and change the species to other oaks from other areas or other trees from other areas in urban settings, how is this going to impact native wildlife?
But I guess the easiest answer is that we expect that native trees, especially oaks, will support more wildlife than non-native trees. And the science on the connection between native species and native plants and native wildlife is huge and global. So we know from thousands of research papers that native trees and native plants across the world tend to support more wildlife than non-native plants and non-native trees. We expect the same to be true in California. That said, there's actually not a huge number of studies on this particular topic in California. However, we know that oak woodlands in California are the most diverse ecosystem, diverse habitat type in our state. And we know that there's a huge number of insects that are highly specialized to oaks. So oaks have a lot of tannins in their leaves, and those tannins are really hard to digest. And so insects that have evolved to be herbivores on oaks tend to be specialized to oaks because they have specific adaptations that allow them to be able to tolerate those compounds. And so what that has led to is a sort of trophic food web where there's a lot of specialists at the base that depend on oaks at the insect level. And then there's also a lot of birds that are pretty specialized to oaks as well that depend on those insects, etc. So what you're left with is a food web that is complex, very biodiverse, and dependent on oaks at the base of the food chain. And so while this isn't a hugely researched topic in California, and we're trying to rectify that at SFEI actually, with some ongoing research to dig into this issue, to have more published studies in this on this topic. What we suspect strongly, based on both what we know in California and more broadly, is that non-native trees are not likely to be providing the same benefits as native trees.
So we'll want to have a mixture where we're going to have lots of our native oaks and native trees, and we can also introduce or have other non-native trees like we already have. As you showed in your first or second slide, we have a major diversity of trees in our urban landscapes, and that's on purpose because people put them there. Dave, your thoughts on that?
So I agree about the biodiversity, but here's the thing. There are also thousands of studies that show that the biodiversity of the planet is currently in motion and migrating poleward largely. So I mean, to me, it's a nuanced question because we've got stuff moving, and as Eureka totally correctly points out, oaks are the foundation of much of the biodiversity in California, but that's true over much of the Northern Hemisphere. Oaks are a foundation of biodiversity. And there are many organisms that depend on specific oaks. If those organisms are moving and their host trees are not moving, that is how you create extinctions. So got to put that in. I also want to say one other thing. I kind of occupy a nebulous space that is between the normal definitions of native trees and the normal definition of non-native trees. What I've tried to find are the closest cousins to the native trees that are already major hosts to biodiversity within their environments. And I'm also not saying that we should move these trees to our wildlands. What I'm saying is that these kinds of potential native trees have a place in our cities where they potentially are an improvement over a calorie pear, an improvement over a London plane, which have no biodiversity components whatsoever. Whereas the close cousins of the oaks, from my experience, and if you look at Apple Park, where we planted 60 different kinds of oaks, and about 40 of them were non-native but habitat friendly, Apple Park is exploding with biodiversity. So critters kind of know what an oak tree is. So there you go. I'm kind of trying to like move right along the edges of the.
I think that what gets lost in the conversation about how to move trees to be where they need to be in the future is the fact that we will likely need to help trees stay in the same place too. So there's the conversation about what are the trees that, what are climate ready trees? What are the trees of the future going to be? That's a huge conversation that's going on right now. And it's mostly focused on what I think is a little bit of like throwing out the baby with the bathwater, is a lot of conversation about how we move trees to new locations in order to keep up with climate change, and almost no conversation about the trees that we will need to protect in situ right now. So the reality is there's going to be a mix, and Igor showed this really nicely. He showed the two range maps of coast live oak and coast redwood. Coast redwood is at the northern extreme of its range in the Bay Area. Coast live oak is in the Bay Area, is right in the middle of coast live oak's range. So some species moving to track climate change won't affect them very much in the Bay Area, whereas others, if they're on the edge of their range, may become unsuitable or suitable where they weren't before. So it's just worth remembering, while it is important to think about who we need to move and which things will be lost, it's also really important to remember that many species will need to adapt in place too. So we need to have a little bit of a nuanced perspective of like trying to think through who are the species that are likely to be okay in the future, we need to protect them in place, and who are the species who are likely to become unsuitable, and who might we need to help shift northward. So that's all I would add, is just remembering to support also species in place.
Mm-hmm. Yeah, go ahead, Dave.
Hey, one other, apologies, lost my train of thought. It happens. Let's go ahead.
All right, so yeah, I think that there have been a few questions around water. And the one I want to kind of pull is, there's a question a bit more directed at Dave. The question, is planting millions or trillions of trees actually an advisable long-term climate urban forest management solution? We need potentially massive irrigation. Is this really sustainable? Do you have any comments on that?
Sure. So the comment about massive irrigation, let's use drought-tolerant trees instead of water-loving trees in the future. There's a huge structural problem with the urban forests of California, where we have been planting non-drought adapted trees for more than a century, and I can't figure it out. So for the future, no, we don't want to plant big areas of trees that need water. And also for carbon sequestration, if you look at the science carefully, we can't sequester a large, our cities don't have enough footprint to plant a meaningful number of trees to have any dent in global emissions. It's not going to be the cities. To me, the cities are much more potential biodiversity corridors than they are climate change mitigation by sequestration. If we're going to do sequestration and we're going to do it right, it's not really going to be in the cities, and it's not going to be commercial species, and it's not going to pay anybody any money. So we probably aren't going to do it, at least until things get really bad. But yeah, we aren't going to fix much carbon using urban trees.
Yeah, I'd
Period.
agree with that. I think adaptation is a different story. There's a lot of adaptation work that can be done by urban trees, but mitigation, yes, the footprint is too small unless we all convert to electric cars, then it would be a different story.
Gotcha.
Igor, I bet you have something to say on the water question too.
Yeah, actually, Igor, I'm glad you're on with us, because there have been a number of different questions around water, but also other factors that would be playing into climate change in our cities that might impact the tree selection. There's questions like, do we have projected wind speed changes, or are there things beyond temperature we want to look at when we're considering changing species? Another one that Matt Ritter brought up was humidity. Could be very, very different between LA and Costa Rica, but the temperature might match in the future. So, what are your thoughts on these different considerations as well, and how it might impact our selection?
So I think I put in a longer answer in the question answer thing, but in brief, yeah, we should consider all of those factors. On the other hand, I think there is a real sort of danger in paralysis by analysis here. You want to start somewhere, and you want to then use those considerations to move forward. So we use temperature. If you read the paper, we use temperature because we thought it was a reasonable proxy to help us select cities. So we didn't, and we intentionally didn't go to Costa Rica. We stayed within California. Yeah, you could use any number of other climate factors, but again, you have to start somewhere. And I think starting with temperature is reasonable. Not sure if you start with a change in wind speed where that takes you. Now, if you have a site that has a wind speed problem now, then yeah, it absolutely makes sense to consider. If you're working in the Presidio of San Francisco, yeah, it makes sense to consider wind speed changes. Just a brief tack on to what Dave and Erica said about planting lots of trees in cities. My perspective is I'm trying to keep multiple sort of perspectives in mind, but from a purely human perspective, yeah, we need to plant boatloads of trees in cities, primarily for the benefits they provide to humans. And we need to figure out how to do it. And we need to figure out how to do it in such a way that it's sustainable in regards to water, that it's sustainable in regards to native biodiversity, so that we are providing wherever we can those benefits, the habitats, the corridors, all of that. But at the end of the day, we're not recreating an oak woodland, because it isn't an oak woodland anymore. It's a city with 1 million people, and you are going to end up with something very different than if you remove those 1 million people and said, okay, we're going to restore an ecosystem here. And I think we do want to draw a fairly bright line between those ecosystems that we're managing primarily for their own worth and for their native biodiversity. And an obvious silly example would be to look at federally designated wilderness. You're not going to build a road in a federally designated wilderness because that's not compatible with the management goal. And then you sort of transition all the way to a city, any city in California, but any of the large cities. Really, the ecosystem management goals there have a very, very large human component. We're doing a lot of things in cities to benefit humans. Again, I would never say that we should just ignore all the other elements, but I am saying that we shouldn't shy away from planting trees just because they hadn't been there before. We need them here now. Think of a number of cities in the Central Valley, think of a number of cities even on the San Francisco Peninsula, where there just weren't humans there. Now there are. And of the various things we can do to make those environments better for humans, trees, as both Erica and Dave pointed out, are one of the few that really also get us a bunch of co-benefits. I don't really like that term, but really address multiple things at once. So yeah, we need to figure out water. We need to figure out species selection. We need to figure out how to protect large trees we have now. We need to figure out especially how to protect large native trees we have now. But we need to continue to plant trees.
Mm-hmm. Yeah, that's great. Thank you. Yeah, go ahead, Dave.
So I totally agree with Igor's approach, using temperature as the primary proxy to get into the range of effects that occur. So, and it sounds like Matt Ritter somewhere mentioned, the one that I find the most, having messed with oaks around here, lots of different kinds, lots of examples, is that the Bay Area seems to have rising humidity levels, because I have watched over 30 years just more and more of the blue oaks that I've planted and the valley oaks that I've planted get really chewed up by powdery mildew during, this time of year. We see it especially in blue oak and valley oaks. Really interesting, because some specific local valley oaks will have really good powdery mildew resistance, and some of them will have terrible resistance. So one of the key things that I've done to grow new oaks and to trial them is to first grow them young trees in an environment that has severe powdery mildew, where there is already enhanced levels of humidity. Because what I want to do is, so we've got a lot of ocean on the planet, we're getting warmer. That should lead to more humidity overall, just a very overall. So along with the temperature proxy, there is a global humidity increase proxy that I won't try to name specifically, but we're seeing it. So to me, what I'm finding is that many of the trees from monsoonal areas are already adapted to higher humidity levels in the summer because they're monsoonally adapted. Quercus rugosa, Quercus oblongifolia, all the ones that I mentioned, we're seeing a remarkable level of powdery mildew resistance that we do not find in the California native deciduous oaks, although it's present in almost all of the evergreen oaks. So in addition to temperature, in addition to changing rainfall and precipitation patterns, I'm raising my hand to say that the kind of micro humidity issue is going to turn out to be really, really critical for what it's worth.
Yeah, thank you, everyone. So I know that we're coming closer to the end of our time together, and Igor's got some closing statements. But I want to just let you know a lot of good questions have come in to the chat. We're going to do our best to provide resources after this that answer many of these. And one topic too that was brought up, there's a lot of savvy people on this webinar that know that species selection is not the only way to manage our urban forests well and to combat climate change. There's a lot of things that we're doing that we're going to talk about more in the next webinars we're going to do. So I think there's a lot of questions that are coming to light and that you're asking about. And I think a lot of these we're going to be answering next month and the month after. So I just wanted to make that note.
And the next month's seminar, thank you, Elise, is going to be on August 20th, where we will hear about the Facebook's Bayfront campus, which was constructed on top of essentially a brownfield site, and now even includes a rooftop forest. So please sign up for that. So August 20th, 10 to 11:30. And again, please fill out the survey as you exit the webinar. Please, please, please fill out the survey for arborists. If you don't fill out the survey, you don't get the CEUs. So I think that's all. Thank you very much, and have a fantastic rest of your day. And thank you, Erica, and thank you, Dave. Thanks, Elise, and thanks, Natalie. This worked great. Thank you.